So let's start off with a packet that has this two-way table in front. What percentage of the students speak a foreign language and have a math average greater than or equal to 90? So there's nothing here that's going to limit the sample. They want to know just what percent of the students, it's not of students who happen to have something. It's just what percentage of students. So you have to figure out how many total students there are. If you add up all these numbers, 65, is it 145? That goes there. And when they say and, let's see, write the percentage of students that speak a foreign language and have a math average that's greater than or equal to 90. So speak a foreign language greater than or equal, that's called the intersection. Where this intersects with that is 70. So that gives me 70 over 145. And these are all as a percentage. So what's 70 divided by? It should be a little bit under 50%. So I'm guessing, if I'm looking at it without a calculator, is it 48? Should be 0.48 something. I don't know if that's exact. Probably not exact. The reason why I didn't release the scores for these is because when you take these retakes, it's the same problem. So it wouldn't make sense to just give you the answers. So if you want the answers, this is about the closest I'll get. Any questions here? A, this is A. This is the one. So it's the one from Monday. A random sample of 200 teenagers participated in a taste test. Each teenager sampled 4 choices of fruit drink labeled A, B, C, and D, and then they were asked to pick their favorite drink. So based on this information, which of the given statements is true, and select all that apply. So 40% of the participants were girls. If this were to be true, we would take all the girls. How many girls are there in total? 80 total girls participated, that's this number, and divided by the total participants, which are 200. And when you divide 80 by 200, you do get 0.4. So that is correct. It's not in order?
Last question.
I didn't mean to go from packet to packet. I thought I had put them in order, but I don't want to take the time to rearrange it, so just find it. It's not a big deal. It's all coming from the same. I thought I had it in order from A and then B, but just find it, I guess. 0.4. So is that true? Are 40% girls? Quicker you answer, the more we get to do. Yes. 0.4 is the same as 40%. 70% of participants refer to A, so my sample is still participants, so I'm still over 200. But now how many preferred A? If I look at it's called the marginal frequency, it's 70. Is 70 out of 200 the same as 70%? No. No, it's actually 35%. It's 0.35, so that's a no-no. 20 out of 120, 20 out of 120 of the boys preferred D. So here, our sample is just boys. We do have 120 boys, that's correct. And out of just those 120, so I'm only looking at this slide, it is correct that 20 preferred D. So that would be correct. 20 out of 120. That was good. 10 out of 35 of the participants who preferred B were girls. So now our sample is participants who preferred B. Out of those, we had 35, so that part is correct. And 10 of those participants were indeed girls. So that's correct also. ACD so far. The proportion. Okay, when you see this word in probability, proportion, just think of percentage. It's kind of weird because in algebra, a proportion is a type of an equation. But here, when they talk about proportion, just think of percentage. So if I were to read this with that word, the percentage of boys who preferred C is equal to the percentage of girls who preferred C. So in each of these cases, we're limiting our sample. How many total boys were there? How many total boys were there? 120. How many of those boys only, because now we're only looking at boys, how many of those boys preferred C? 30. 30 out of the 120. So we want to know, is that equal to how many total girls were there? 80. And out of those girls, how many girls preferred C? So is 30 out of 120 the same as 30 out of 80? Well, we can tell since the numerators are the same and the denominators are not, that's not going to be true. You could divide it if you wanted to confirm it. You could do 30 divided by 120, which would give you 0.25. Or we can do 30 divided by 80, which is like 0.375, I think. They're not the same. One other thing you could even do is cross multiply. Because if this is going to be true, then that times that would have to be equal to that times that, which it obviously is not. So the answers here are A, C, and D. Right, Sam? Sam agrees. Which packet is this one in there? I thought I had put them in order. Now it jumps to the bottom. Right. Deannie collects data for a market research company on the number of dollars men and women spend on video games per year as a function of their age, and then she models the data using linear functions. The correlation coefficient. So that's the same thing as like the R that we talked about when we did scatter plots. What's the strongest correlation coefficient you could have? A 1, or a -1, and then the weakest would be 0. So the correlation coefficient for men is 0.30. The correlation coefficient for women is 0.15. Which statement correctly describes the meaning of correlation coefficients? That men spend approximately twice as much as women on video games? No, the correlation coefficient doesn't have anything to do with how much they're spending. It just like all this is telling you is that there's a stronger relationship between men and what is it? Between the number of dollars that men spend on video games than on women. So it's not going to be A. The function for men represents the amount they spend on video games better than for women. Yeah, that's a pretty good one. Because it's saying that there's a stronger relationship there. So for right now, that's the best one. Now we want to read all of them because we want to see if there's one that describes it better. But so far, B is the best one. Men spend the most on video games at age 30, and women know that the correlation coefficient has nothing to do with age, so it can't be C. Men increase the amount they spend on video games by 30% each year, and women know it also has nothing to do with how much it's increasing. Correlation coefficient is a number that measures how strong the relationship is, and out of all of these, the only one that talks about how strong of a relationship is B. Shobi, so yeah, I probably because I put the two files together this morning, and I could have sworn I arranged it for Mondays to come first and then Wednesdays. That is how it's arranged on your one packet is Monday, one packet is Wednesdays B. But I don't know what happened when I dragged them together, so you just gotta find them. Okay. How about is this one still part of the B or is this back to A now? Do you remember how to calculate this? We didn't do this that long ago. What the first thing you have to do in order to calculate mean absolute deviation is first calculate the mean. What is does anybody have the work? Oh, you know what? You know that I always forget to do this. I'm not gonna forget today. this to put a name on it. This one. While I'm passing this out, can somebody calculate the mean for you? What do you get? Do you agree with that? Does your calculator tell you the same thing? Oh, I don't know if you, also if you noticed, I had a couple students in a different class that asked me if I could post the final schedule on each class, so I did that even for you guys too. So if you want to see like when you test in each class and what the schedule's gonna be, I posted that up. All right, so Marquis says that the mean is 16.2. Does anybody disagree with that? So then, in order to figure out what the mean absolute deviation is we gotta calculate the absolute deviation between this mean and all of those numbers. We have to get a positive each time, but we just want to know how far away are each of those numbers from 16.2. So 5 is going to be 11.2 away. 7 is going to be 9.2 away. 8 is going to be 8.2 away. 12 is going to be 4.2 away. 14 is going to be 2.2 away. 18 is 1.8 away. 19 is 2.8 away. And by the way, I'm getting that by subtracting. If you're not sure how I'm getting those numbers, you just subtract those numbers. You can do it either way. You can do 16.2 minus the number, or you can do the number minus 16.2. Just make sure that you always make it positive. 21 is what? 4.8. 25 is 8.8. And then finally 33 is going to be 16.8 away. So if you add all those up and then divide by how many there are, which is 10, what do you get? What is the mean absolute deviation? All those numbers added up, divided by 10. Seven. Okay. Any questions there? Which packet is this one on? Still Wednesdays? All right, though, the rates of change of two functions are being compared. One function f of x is represented by this equation. What type of function is that? Linear, that's a good word, very good. And then the g of x is represented by the table below. Which statement is true? That the rate of change of f of x is greater than the rate of change of g of x. All right, so we're just comparing rates of change. Well, see, here's the thing. Linear functions are the only ones that have a consistent rate of change. That no matter what 2 points I pick, I would always get the same slope. I can't tell that by looking at this. Because like with tables, what would happen is here on the y, you would see a common difference. But you can only check for a common difference if this is increasing at a consistent interval, which it's not. So what you have to do then, function. They give you an interval. Rate of change is greater than the rate of change of g of x. The rate of change is greater than the rate of x. You'd have to, I guess, check the slope for, because here this one the slope is 4. That one's obvious. The slope, the rate of change is going to be 4. That's what rate of change means. The slope. The other ones you have to take turns. You'd have to take the slope of these two, these two, these two, Um, Probably even have to jump like also like these two, and then the last two. But I think if you do those three and they all come out the same, you could be pretty sure that the other ones would also. So like if you do here's another like if you're wondering how I do slope quick in my head, to get from negative right because it's rise over run. To get from -2 to 4, what are we doing? No, you're adding 6. From -2 to 4, this is +6. But then from -1 to 1, what are we doing? It's +2. So rise over run with 6 divided by 2 is 3. Okay, to get from 4 to 7, what are we doing? Yeah, we're adding 3. To get from 1 to 2 is +1. 3 divided by 1 is 3. Okay. To get from 7 to 16 is +9. You're adding 9. 16 is 9 bigger than 7. Here's from 2 to 5 is +3. 9 divided by 3 is 3. Uh, I'm not sure if you can come up with a counter example, like something that would prove that this is enough. I think technically you're also supposed to have to check like look. Let's check one of them to see. From -2 to 7 is +9, then +3. Yeah, that still comes out as 3. From 4 to 16 is 12. From 1 to 5, yeah, 1 to 5 is 4. That's still so everything is coming out as 3. So which one of these is true? That f of x has a greater rate of change. Its rate of change is 4. The table is 3. This is a graph of f of x is equal to 3 to the x and its image. Okay, so in algebra one, because I get confused, but I taught also geometry. Did we use that terminology, image and pre-image? Because I know we did transformations, but I don't know. I don't remember we used those words, image. The pre-image is before a transformation, and the image is after a transformation. So what they're saying is that this f of x, like f of x turned into h of x. They both appear to have the same asymptote, so it doesn't look like a vertical translation occurred. Um, so the only thing that could have occurred is some type of a multiple. And since h of x looks like it's increasing faster, just look at the y-intercepts. Um, the y-intercept of f of x is at 1. The y-intercept of the other one is at 2. It's increasing faster. Um, which of these looks like occurred? Definitely couldn't be A, because if it was going to be A would be the first one I could eliminate. Because if it was A, the asymptote would have changed. They both have the same asymptote, so I know it can't be A. I know it can't be C also, because if C would have happened, if I was dividing it, well, and you know what, you guys, we didn't even cover those types of, but if I were to divide the x by 2, well, actually, fine. Let's just do this so it's easier for you to understand. Let's just pick a point and then see what happens with a point. So like here, since we focused already on the on the y-intercept, right? What is the x value on the y-axis? It's 0, right? So let's see. Uh, at f of x, I'm getting 0, comma 1, and then on h of x, I'm getting 0, comma 2. All right. So how can I say this? If I put in that 0 for x here, 0 plus 2 is 2. So does the y value of f of x at 2, which is when x is 2, it's somewhere up here, is 8 the same as 2? No, it's not. Those two are not equal. The value, the better way to do it. Let's do it this way. If I put a 0 for both of them, right? Because I'm putting in a 0 for x, there's two x's there. What is the value of function h at 0? When x is 0, what do I get for function h? It's on the board right now. 2. Yeah. When on function h, when x is 0, y is 2. But on function f, when x is 0, if it were to be 0 plus 2, 0 plus 2 is 2. So what is function f at 2? Well, we saw it's up here somewhere around 8. Are those two the same? Is 2 the same as 8? No. So it can't be b. Okay. Now we're left at these. And okay, this can get a little tricky here because if I put in a 0 for this one, actually never mind. I take it back. It's not going to be tricky. I take it back. It's not. What's 0 divided by 2? It's still 0, right? So is h at 0 the same as f at 0? No, they're not. One of them is at 1 and one of them is at 2. So it can't be that one either. Whereas if you look at the other one, again, what is h at 0? What is the value of function h? What is the y value of function h at 0? Yeah, this side gives you 2. And then even though f at 0 is 1, this 2 in the front is multiplying, so what is 2 times 1? It's 2. That's the only one that's equal. So basically function h had a vertical stretch of 2. Read, that's confusion face. This point is 0, 1. It belongs to function f. This is 0, 2. It belongs to function h. If I put in a 0 for each of them, if I put in a 0 for h, what do I get out? I get out a 2. If I put in a 0 for function f, what do I get out? I get out a 1. But then this 2 in front is multiplying. So what is 2 times 1? It's also 2, which makes them equal. That's the only one that had happened on. Right, Caleb? There's too much effort coming from that direction, and you gotta tone down the effort a little bit. An environmental scientist is conducting research on a particular type of air pollutant. She collects the air samples over time and determines that the average number of micrograms of the pollutant in a cubic meter. Her data is shown below. Which function best? Okay, so notice how the time, which is the independent, that's going up at a constant interval. They're going up by 1, which is good. Because then now that means I can look at these numbers and see if there's a pattern. Okay, the two patterns that we studied were linear and exponential. In order to be linear, these would have to have a common difference. But like, look, this here is minus 6. This here is minus, looks like 5.3. This one here is minus 4.6. So that's definitely not common, so it can't be linear. Anything that's linear has to go bye-bye. So bam, A and B it can't be, because it can't be linear. The other one that we studied, the geometric relationship, is exponential. Okay, now this could be exponential. If it was exponential, there would be a common ratio. Now, are the y's, as the x's get bigger, are the y's getting bigger or smaller? They're getting smaller. So if I were to test any of these out, which would be the first one I test out? I would test C, because C looks like a it's like if it's a decay. What is the original amount? It is 50. If I were to plug in a 0 for t here, anything to the 0 power is 1, and 1 times 50 is 50. But then, I mean, I guess you could plug in if you want. You can substitute 1, substitute 2, or you can just check by doing 44 divided by 50. See what you get. That is 0.88. You could do 38.7 divided by 44. See what you get. It should be, I'm guessing it, I'm hoping it's 0.88. You could do 34, always the one after divided by the one before it. 38.7, assuming this is correct, it should be they should all give you a common ratio. All of those should give you 0.88. Might be rounded a little bit, but no, it's not supposed to. I don't like rounding. Of all of these, that's the only one it could be. What type of an exponential function is being shown on D? a growth, and there's not a growth, the numbers are getting bigger, they're getting smaller. Let me know if you need a second to find these things. These are all pretty much sticking to the Wednesday. Wow. Right. So this function is graphed below. What change would be seen if f of x plus 2 were graphed? They don't even need to show you a graph. If the plus 2 is occurring outside of the parentheses, where are we shifting? Up. It'd be up 2. I could have given you that without even showing you a picture, and it wouldn't make a difference. You should know it's C. How about if that would have been a minus 2 on the outside? Where would you be going? Down. How about if it would have been a plus 2, but inside the parentheses? Where would you be going? Left 2. Good. How about if it would have been a minus 2 inside the parentheses? Right, yeah. When it's inside the parentheses, it's counterintuitive. Plus takes you left, and minus takes you right. These were only the ones missed the most. Which runner has a faster average speed from 20 to 31 seconds? Okay, so below is a graph and a table, so it looks like you can use either one. I guess I prefer to use the table. Average speed is another way of saying average rate of change. Yeah, because those numbers are in meters. So runner A between 31 and 20 seconds. At 31, he was at 287, and then at 20, they were at 168. Runner B between 21 and between 31 and 20 seconds, they were at also 287 at 31, but then they were at 213. 287 minus 168 is going to be 119, I believe. Somebody check my math. And then this one's going to be 74. So if it isn't obvious already, like as to which one's bigger, you could divide them. They're very easy to compare because the denominators are the same. We're looking over the same interval. Runner A covered more distance in the same amount of time, so they're obviously the one that's going faster. It's runner A. I'm recording all of this and it'll be online also if you want to go back and watch these. Find the average rate of change over the given interval. Okay, I'm doing this even now with my trailer courses. What's another word for average rate of change? Slope. So let's what they're giving us are the x's. Okay, that this is not a point. Those are the x's of two different points. I need to find the y's. You can plug them in the conventional way, or you can do the shortcut that I showed you, which made you cooler amongst your friends. The synthetic substitution. The first one, when I plug in a 1, it gives me 2. Sam, let me know if I'm blocking you out. When I plug in a 4, that gives me -7. So Slopey is 2 plus 7 over 1 minus 4, which is 9 over -3, which is -3. On the Google form, he would have just put -3. That's what Caleb did. He just put -3. Coincidentally, also when I asked him how he would rate his level of paying attention right now on a scale from 1 to 10, he also said -3. It's just the weirdest thing. Recursive formula. What is the 30th term? All right. So when you want to find a term off in the distance, if you're going to do so recursively, you'd have to do it one by one. So what this is telling you here recursively is that we're starting with 4. So the question is, and look, and we're supposed to be adding 6 each time. What type of a sequence is this? If we're adding 6 each time. Arithmetic. So do I want to add 6 30 different times? If you feel you have the patience for it, be my guest. I don't. I'd rather just be able to plug in a 30. In order to be able to plug in a 30, you need the explicit definition. So the explicit definition in this case, and I'll just go ahead and plug in the 30 from the beginning, is the original amount, which is 4, plus the common difference, and then times n minus 1, which in this case the n is 30 minus 1. And that does everything that I needed to. So it's 4 plus 6 times 29. Is that 4 plus 174? Putting it in my head, which gives me 178. Oh, I know what happened. I did it right, but then I started on the wrong slide. Okay. This has all been Wednesdays, right? And now we're getting to, this is the last one from Wednesday? Okay, good. All right, that's fine. So it won't be that bad. This is just memorization. I doubt this is going to show up on the test, but I left it on the practice test because I thought it would have been easy. Out of the 3 trig functions, which you won't even see in Algebra 1, but you'll see them in Algebra, you'll see them in geometry actually. In Algebra 2, sine, cosine, and tangent. Those are the 3 trig functions you'll see. Which ones are even? Only cosine. Cosine is the only even one. What are the other 2? Oops. The other 2 are odd. None of them are going to be neither. These are called sinusoidal functions. Or at least the first 2 are. They're oh geez, what? It's not sinus. There's another word. I'll think of a word. There's a word that says periodic. These are all periodic functions, which means that they repeat. Because they repeat, that's what makes them symmetrical. It's just a matter of what type of symmetry they have. That's the only difference. Okay. So then let's actually go back, because that's what happened. I just started on the wrong one. Let's go back to the beginning and do the first one from Wednesday, and then we can switch back to Monday. So what is the relative frequency of students who like tennis, soccer, or both? This is a repeat question. I remember Anne getting confused with this one before one time when we were doing the statistics unit. The key here being or. Okay. We're not limiting our sample. Our sample here is still all students, so you would have to add everything up, and that I believe these all add up to 100. There's 100 total. So if we're allowed to like tennis, soccer, or both, okay, well this is the both. These are the ones that only like tennis but not soccer, and these are the ones that like soccer but not tennis. The only people who are being excluded here, the only people who are not part of what we're looking to count are the ones that don't like anything. Those 22. So then how many here qualify? What is that, 78 out of 100 would qualify, which is 78. Next year in geometry, you're going to start getting more into probability. And you'll learn that word or usually implies addition, that you add. And then when you see the word and, you'll see that it implies multiplication. So then we go back to Monday, and Monday we already did this first one. And please tell me that now this is the second one from Mondays, from practice test A. All right, we're making pretty good time. The table below shows the values of a function, which best describes the function based on average rate of change. Shows the values of a function. Okay, so they want to know, is the function linear, not linear, so everything has to do with is it linear or not. So this is kind of simple. Look, we can do slope formula if you want. But if all we're doing is checking to see if this is linear, let's just check differences. Every single one here is going up by 2. So as long as all these other ones are going up by the same amount, it doesn't matter what that amount is, it's going to be linear. From 7 to 11 is how far? From 11 to 15 is 4. From 15 to 19 is 4. So yeah, this is going to be linear. If it were to ask you what's the rate of change, well, these are rises, these are runs. What's the rise over run? What's the 4 divided by 2? Yeah, so the function is linear because the average rates change about the same. 2. This problem was meant to throw you off because you guys focus on this so much because you're so used to being given problems where the answers is just like 1, 2, 3, 4 where they go in order. But then on something like this where they're jumping by 2, I haven't looked at the data like that specifically, but I would guess if you missed this, assuming you know what you're doing, the most common missed answer would have been C. You would have been tempted to put C because you see the going up by 4. When you forget, you have to divide by the 2. 3? That's so. Okay, all right. Yolanda bought a new car for $8,000. She knows that if she takes good care of the car, that its value will decrease by only 10% each year. After a certain number of years, the car will be worth, okay, according to the formula. So you do not have the model. They gave it to you. How many years will it take for the car's value to decrease to? All right. If you have a calculator, take it out. I'm going to teach you something. You have a look. Assuming you do not know what I'm about to show you, the only way I would treat this is start off at 8,000 and start hitting 0.09 or times 0.9 times 0.9 times 0.9 times 0.9 and figure out how many times you had to hit times 0.9 to get to 5832. That's one way of doing it. Here's another way, and then look, you're not really. This is not part of the curriculum, but it's just if you can learn this thing, you can learn how to do it on the calculator. You'll get the calculator answer for you. You have not learned how to isolate a variable when it's an exponent, but I'll show you very quickly. Okay? What you gotta do, you have a button called log. Okay? So you want to take the log of this number that's by itself, so it'd be 5832 divided by the original. So here, I'll even write it down better for you. So take the log of the final divided by the initial amount. Depending on how like most of your calculators have 2 lines, so you can just actually type it as you see it and hit equals. But then you have to divide that by the log of the base, of whatever the base is. I'm not going to get into what log means, like that hasn't been part of it, but this is just another way of doing it so that you don't have to hit times 0.9, times 0.9, times 0.9. Then Nakai's going to get mad if he doesn't have a calculator. So, did you get it to work, Ann? Did you get a number for that? You have that one. Oh, you didn't have a solver? Learn this one. So hit log, put 5832 final divided by. I just want to see if somebody can know how to do it. You don't have a calculator, Kiara? Did you get some marquees? You got 3. I left this one multiple choice on purpose to accommodate the people that had to do it by trial and error. I mean, in worst case, you could have just plugged in a 1, plugged in a 2, plugged in a 3, plugged in a 4 to see which one works. You're technically not supposed to know how to use logs, but if you do it, it's kind of like how I showed you some depth substitution to help you out. Several input and output values of a function are shown in the table below, which is the best interpretation of the average rate of change of this function. All right, notice how the x's are all going up by 1. Average rate of change means slope. Let's look at the y's. This one's going up by, oh, I don't even need to check what it's going. Can you guys tell what the y's are doing? What is it? They're being multiplied by 2, which means it's exponential. And the common ratio is 2. So as x increases by 1, f of x increases by 2, no. Increases by 2, no. By a power of 2. It's not by a power of 2. That's not a good word. 2 squared, 4 squared. It should be by a factor of 2 maybe. As x increases by f, before it's linear. Okay, it's definitely not linear, so it can't be a. We know it's exponential. Exponential, so it can't be c. It's gonna be d, but that's not a good word there. Power is not a good word. A better word for that would be a factor of 2. The factor means you're multiplying. I didn't even notice that. This function and its reflection are graphed. Which algebraic function best describes the transformation? So I didn't even need to see it. Because when you reflect, what transformation number causes a x-axis reflection? Huh? Well, negative where though? Where a is. And that's negative in front of the reflection. Right? Because it didn't say anything else, right? Doesn't matter the function. Finish. The heights of inches of the players of the Bluebirds baseball team. Okay, they give a model. The manager determined that the team's lower quartile height, which is Q1, is 65, the median is 68, and the upper is 70, which spot. So just check which one of these has a Q1 of 65, a Q2, which is a median of 68, and then a Q3 of 70, which are all in the box. It can't be A because already the lower quartile is not where it should be. It should be 65. It could be, let's see, B 68, 70. It could be that, but I haven't checked the. I guess I'd have to go back and look at the data to see the extremes. But so far, it could be B. It can't be C because of the again, it says Q1 has to be 65, and it could be D. So it's between B and D. So now let's go look at the max and the min. 62 and 74. It can't be B because B is at 60. Here 62, 74. There you go. We didn't check for outliers, but I'm assuming that it would check out. That there would be no outliers. I just checked Q1, Q2, Q3, and the max and the min. Scatter plot. The community pool manager tracked the air temperature and the pool attendance throughout the summer. The results are shown. Based on the scatter plot, which best describes? Okay. You see this word here? So we didn't really go into the differences between what's called correlation and causation. Okay. Anytime that there's a relationship between two variables, okay, then we can say that there's a correlation. But now, if there's also a cause and effect relationship, if one event directly led to something else, like if you were to study all the weather as to, compared to when people wear raincoats, well, yeah, there'd probably be like a pretty strong correlation because when it rains, people wear raincoats and stuff. But as far as causation, it's very difficult to prove causation. Okay, and the saying always goes, correlation does not necessarily imply causation. So in order for there to be causation, you'd have to have a correlation coefficient that is like, right, 0.99, 0.98, all the way to, it has to be almost perfect if you're going to have causation. This does not look to me to be perfect. It's somewhat linear, but that's scattered enough. So the ones that have this word causation, caused, I'm going to ignore them. Now this is a better word, correlation. So is there a positive correlation or is there no correlation? Yeah, I'd say it's pretty, it's close enough where I can say it's in a positive. It's going up right, down left. Ruth and Hilda took a summer road trip. They started in Gloversville and drove 100 miles on the first day. On the second day, they drove a total of T hours and blah, blah, blah. They already gave you the function. What does each term represent? Okay. What are we measuring? What does V stand for? Distance. And if they want to know what does each term represent? Well, these are terms. And since we're measuring distance, each one of those should be some type of a distance. So we can tell already that the 100 is going to be what they drove on the first day, and then the 60 T is whatever they drove on the second day. 100 on 60 T. Okay, 60 T is not the rate of speed. 60 would be the rate of speed. D is the total distance. 60 T is the difference on the second day, and 100 is the amount of time. No, 100 is not a time. 100 is a distance. But it's going to have to be D. Yeah, D. 100 is a distance, 60 T is a distance, and D is a distance. The parent function. So which of these? Okay, look, on a parabola, if you want to only tell translations, look at the vertex. That's the easiest way to tell a translation. Jada, you're my expert on translations. Where am I translating because of with those two? Use your words. 2 to the right and 3 up. Which of these has a vertex that 2 to the right and 3 up from the origin? B. Okay, we're back to these runners now. So which one had a faster average speed of from 9 to 31? Okay. Well, look, let's do this because we're running low on time. Would we agree that we're not comparing apples to oranges? For both runners, we're looking at the exact same time interval. Like, how much time passes between 9 seconds and 31 seconds? 22. There's 22 seconds. So if you're going to have a faster average speed over those 22 seconds, you have to cover more distance. Well, runner A went from 120, meters, to 287. But runner B did the exact same thing over the time interval. So what's their speed going to look like? If their distance is the same and their time is the same, what is their speed going to be? Find the first term of the arithmetic sequence with a common difference. Okay, so here you use the formula again. The common difference, so the first term. The last term is 75, or it's the 20th term, is equal to the original one, which is what I'm looking for, the original amount, plus the common difference, 20 minus 1. So 75 is the original amount, 4 times 19, 75 is the original amount, plus 76 minus 76. That's it, right? That is it, right? So the first term is -1. Because the 20th term is 75. They said it was arithmetic. What is the 9th term of the geometric sequence? Okay, geometric 9th term. So the 9th amount is equal to the first one, 3 times. What's the common ratio here? It's 3 to the 9 minus 1. So can somebody with a calculator tell me what that is? 3 times 3 to the 8th, or you can just put 3 to the 9th, that's it. 3 to the 9th power. Somebody with a calculator so I can do it before the bell rings. No, 3 to the 9th power? 19.6. 83, okay? And then the last one, before you go, determine whether this is arithmetic, geometric, or neither. It's definitely not arithmetic, because we're not adding by the same thing. But look, how do we get from 5 to 5 over 2? Divided by 2. How do we get from 5 over 2 to 5 over 4? Divided by 2. Like, look at how the bottom is the denominator is being multiplied by 2. Because that's because you're multiplying each time by 1/2. So what is it? Arithmetic, geometric, or neither? Geometric. Hey, it looks better. All right, so I just covered 2 days for you. If you're going to do any of these retakes, it's got to be by Friday night. I will check it over the weekend.